question through this, feel free to put them in the question box, which is part of your interface there. And we will either get to those as Zach is presenting or at the end. We have a sort of a Q&A session at the end if you have anything sort of outstanding that you'd like to ask. So why don't you take it away, Zach, and thank you very much for doing this.
Thank you, Doug. I'm excited to be here today and to present the climate and drought outlook for the north central U.S. region. The summer of 2021 has certainly been one for the record books, with extremely hot and dry conditions in the upper Missouri River Basin. There have been, these conditions have contributed to extensive and unprecedented drought. However, conditions have been much more favorable in the southerly portions of the region. There's a lot to cover today, but before I get started, I wanted to mention that my presentation today draws from information, data, analysis, and many helpful discussions across state and federal partners. Specifically, regional climate services for the north central United States are provided by the National Oceanic and Atmospheric Administration, NOAA, U.S. Department of Agriculture, the National Drought Mitigation Center, Midwest Regional Climate Centers, the American Association of State Climatologists, as well as state drought task forces. And just so you don't miss it, the next webinar will be on September 16th at 1 p.m. Central, and the presenter on that day will be Brian Fuchs. All right, my presentation today will focus on how the conditions we've experienced in the last couple of months compare to historical conditions, how these conditions affect our progression into the remainder of the summer and going into the fall, some of the current and prospective impacts that we have experienced, and a discussion of the recent climate and drought outlooks that were released early this morning. I'm going to attempt to complete all of this in the next 30 to 40 minutes or so, and we'll wrap up for time with questions and further discussion at the end. May and July temperature precipitation rankings. Okay, so let's start by taking a look at temperature and precipitation rankings for the last 3 months. In general, there's a separation of hotter and drier than normal conditions in the northwesterly portions of the region, contrasted by relatively cooler and wetter conditions in the southeasterly portions of the region. These rankings are from NOAA's Climate Prediction Center and compared May through July average temperature and precipitation to those that have occurred over the last 127 years. Larger numbers, up to 127, indicate very warm conditions in red on the left or very wet conditions in green on the right. Smaller numbers, down to 1, indicate increasingly cooler conditions in blue on the left or very dry conditions in brown on the right. The figure on the left shows statewide temperature ranks. In general, the majority of the high plains and upper Missouri River Basin have experienced above average temperatures for the last 3-month period. In Montana, only 2 years of the last 127 have had hotter average temperatures. Similarly, North Dakota and Wyoming have also experienced exceptionally warm conditions, contributing to extensive drought across this portion of the region. In contrast, Missouri, Illinois, Kansas, and states to the south and east of these states have largely experienced near normal or cooler than normal conditions, as you can see. While average temperatures were relatively normal in the Midwest, it should be noted that in general, maximum temperatures in the region were relatively low, while minimum temperatures were relatively high. Moving to the right, the 3-month precipitation rankings tell a similar story. It's been relatively dry in the northwesterly portions of the region, contrasted by relatively wet conditions in the south and southeast. Montana, North and South Dakota, and Minnesota have experienced much below normal precipitation over the last 3 months, with Wyoming, Nebraska, and Ohio receiving below average rainfall totals. This gradient of rainfall continues towards the southeastern portions of the region, with average precipitation in Kansas and above average precipitation in Oklahoma, Arkansas, Missouri, and Illinois. Recently, Illinois has experienced some significant rainfall events with exceptional rainfall totals. For example, between 7 inches and 10 inches fell in about 6 hours or so over 100 to 150 square mile area centered around Gibson City in Ford County, which has contributed to significant and extensive flooding. Here I've shown the same maps as the last slide, but with temperature and precipitation rankings for July only. So a 1-month period instead of a 3-month period. Patterns of temperature and precipitation in July were generally similar to those between May and July. In the High Plains region, you can see that the majority of the states are warmer colors, indicating generally above average temperatures. For the Midwest, temperatures were closer to average, and to the south and southeast, temperatures were average to slightly cooler than normal. So all in all, the 3-month and 1-month temperature patterns were relatively similar. Moving on to precipitation on the right, unfortunately, Montana, North Dakota, and Minnesota saw much below average precipitation for this time period, continuing the trend of drought in this region. In Minnesota, there was only one drier year on record. Nebraska also experienced below average precipitation. However, the remainder of the region enjoyed average to above average precipitation. So let's move forward into August and see what we've experienced over the last couple of weeks. On this slide, I've shown the minimum temperature departure from normal on the left and the maximum temperature departure from normal on the right for August 1st through the 17th. Temperatures from this window of time are compared to the observed conditions between 1991 and 2020, so the most recent climatic normal. Gray colors indicate near normal temperatures, green colors represent cooler than normal temperatures, and orange to red colors indicate warmer than normal temperatures. Generally, minimum August temperature anomalies, shown again on the left, have been between 2 to 6 degrees warmer for eastern Montana, portions of the Dakotas, Minnesota, Wyoming, and Colorado. The remainder of the region has experienced near normal minimum temperatures over the last 18 days. However, Iowa, Kansas, along with northwestern Nebraska and southeastern South Dakota, have experienced slightly below normal minimum temperatures. Moving to the right, again, looking at average maximum temperature anomalies, we've seen generally 2 to 7 degrees above normal temperatures for Montana, Wyoming, Colorado, the Dakotas, Minnesota, Nebraska, and parts of Kansas. Average maximum temperatures have been below normal in Missouri and parts of Illinois, with the remainder of the region experiencing near normal maximum temperatures. So again, similar patterns in this northwest versus southeastern portion of this region, kind of creating different conditions. Moving on to precipitation, this is August precipitation up through August 19th as a percentage of the average value. So as an example of how to read this, dark red areas represent about 0 to 10% of average or almost no precipitation, while gray areas represent about 100% of the normal precipitation for this period. So average precipitation over this, say, 18 days. Blue to purple shading indicates upwards to 200 to 300% or up to 3 times the normal precipitation in this area. Precipitation patterns for this time period have been very spatially variable. Locations with above average precipitation are generally localized as opposed to widespread. Central Montana and central Wyoming have experienced above average precipitation. However, portions of eastern Montana, the Dakotas, Minnesota, Nebraska have all experienced well below average precipitation. Now, even though some places have seen larger than expected precipitation, it's very important to note that in much of the western portion of this region, August is a climatologically dry period. So numbers well above average may not necessarily represent large precipitation totals in the absolute sense. The recent months' lack of precipitation in the northwestern portions of the region have set up extremely dry soil moisture conditions. On the left, I've shown the Climate Prediction Center's modeled soil moisture percentile rankings for August 18th. Low soil moisture percentiles from 20 to 1% are indicated with light orange to red to dark red coloring. Surpluses of moisture with percentiles from 80 to 100% are indicated by light green to dark green shading. This map shows how strikingly different the northwest and southeastern portions of this region are in terms of soil moisture storage. Much of Montana, North Dakota, Minnesota, and Wyoming are in the 1 percentile class of soil moisture. This extraordinary dryness is contributing to unprecedented drought conditions across the region, with excessive impacts across almost all sectors, as I'll discuss more in a few slides. Locations with soil moisture surpluses for this time of year include Illinois, parts of eastern Missouri, and Wisconsin. Shifting to the figure on the right, the extreme soil moisture conditions in the northwestern portions of the region can also be seen in the USDA topsoil percent short to very short map. Here, darker colors represent drier conditions. As you can see, patterns are relatively consistent across these two data sets, with Montana and the Dakotas representing the driest states in this region. In fact, this week, Montana overtook Washington State as the driest state using this metric. Looking directly at current streamflow conditions, here's a map of the USGS stream gauges and flow rankings across the Plains and Midwest regions for the last 28-day period. Across the gauge network, black to blue symbols indicate greater than 90 percentile flows for this time period. Light blue represents the 75th to 95th percentile. Green, 25th to 75th. Orange, the 10th to 25th percentile. And red to dark red represent less than 10th percentile flows. The long-standing precipitation deficits, in conjunction with enhanced evaporative demand driven by these warm, dry atmospheric conditions, and the resulting lack of soil moisture, have led to very low streamflow values in many locations. Many streams, including the Missouri River near Great Falls, Montana, are below the 10th percentile for this time period. In fact, this gauge at Great Falls, Montana is reporting flows in the 3rd percentile over this time period, this 28-day time period. Once again, the theme of this discussion emerges with contrasting conditions in the Northwest when compared to the Southeast. So what does this long-standing moisture deficit and high temperatures in the northwestern portions of the region mean for reservoir storage in the Missouri River Basin? This graph shows the combined storage capacity for Fort Peck, Garrison, and Waukee reservoirs in millions of acre feet. The green line shows system storage in 2019, and the red line is this year. The dashed blue line in the middle represents the average storage over the system, or for the system over time. Currently, system storage is below average for this time of year, and as you can see, storage is declining fast. According to the Northwestern Division of the Army Corps of Engineers, upper basin runoff during July was only 34% of average, and the Fort Peck July runoff was the record lowest in 123 years. Runoff through the first 10 days of August has generally followed this same suit. System storage is decreasing at a rate of about 500,000 acre feet per week. Therefore, we can expect to see the upper 3 main stem reservoirs drop nearly 8 to 12 feet below desired levels over the next 6 months. At that point, the rate of decline will drastically lessen as we reduce to minimum winter releases. What's particularly striking to me about this graphic is the lack of recharge that occurred this year. For example, compare this year's storage dynamics to those of 2019 in April, right here. There is very little total recharge this year compared to 2019, and this is an impressive and troubling difference in reservoir storage. Let's take a look at today's drought monitor that was released this morning from the National Drought Mitigation Center. In response to the multitude of drivers and indicators, many of which we've covered today, drought has been generally extensive and persistent this summer across the northwestern and central portions of the region. North Dakota experienced an early onset to this season's drought, which has remained and expanded for the last several months. Wyoming also experienced an early onset of drought, but had a brief period of relief, followed by yet more degradation. Drought in North Dakota subsequently expanded south into South Dakota, with the most extreme conditions in South Dakota remaining centered around the northern border. As the drought was intensifying in North Dakota to exceptional or D4 conditions, the most extreme class of dryness, this dryness expanded to the west into eastern and northeastern Montana, where it's been expanding ever since. Drought also began to intensify in Minnesota starting in late June, and by mid to late July, extreme drought was identified and expanding. Currently, the majority of North Dakota and Montana are in extreme to exceptional drought. In fact, the entirety of Montana and North Dakota, 100% of the land area, has been designated as a D1 drought or worse. Roughly 74% of North Dakota is in either D3 or D4 drought, which are the most severe drought classes, where the same statistic for Montana is roughly 73%. These are truly unprecedented series of statistics. Drought is also exceptionally widespread across South Dakota, Minnesota, Wyoming, Nebraska, Colorado, and Iowa. And a patchwork of drought is apparent across the remainder of the region, but not to the same expanse and intensity as in the northwest and north central portions of this region. There have been and are currently many, many impacts related to this ongoing drought. There are too many to cover comprehensively. However, I would like to point out a couple of key examples. Images like this on the top left have become the norm across most of eastern Montana and the Dakotas. And in Minnesota, dropping water levels have made some docks unusable, as seen in the picture on the lower left. The state of range and pasture conditions have continually deteriorated throughout the season, significantly limiting forage for livestock. Therefore, supplemental feeding is generally required to maintain livestock condition. However, as the supply of forage decreases and demand for hay increases, the price of supplemental feed is increasing, making it difficult for ranchers to meet their anticipated cattle weights. Water holes for livestock are drying up and require significant maintenance to provide any water, and in some cases, water has become completely inaccessible to stock ponds. Beyond the immediate impact of low precipitation and hot temperatures on pasture conditions, grasshoppers and blister beetle emergence have further decimated hay crops and are pushing cattle producers to sell off herds. In Montana, the drought is also impacting many other sectors, such as the recreational and outfitting industries. Hoot owl restrictions on waterways, which have been enacted across the state in many of the state's most famous cold water fisheries in response to rising river temperatures and low water availability, limit fishing to midnight through 2 p.m., which limits the outfitting season significantly. This season has also experienced early season fish kills, unnaturally warm water temperatures, and low trout numbers in general. It is also notable that for the first time ever, D4 drought has been identified in Minnesota. Here, lake levels are dropping in response to lowering water tables and depleted groundwater. In some cases, this is affecting well usage as well as water tables drop below screening depths in these wells, especially in sandy substrates. Soil moisture in some sites in Minnesota are the lowest since the drought of 2012. Emergency declarations by governors, such as those in Montana, North Dakota, and South Dakota, and others, are easing restrictions for hauling hay, water, and livestock in response to this historic drought. Now I'd like to take a quick look at some of the NASS statistics for pasture and range conditions. On the left, we have a map showing the percent poor to very poor pasture and range conditions for this region. So larger numbers in this plot and darker colors represent worse and worse pasture and range conditions. As you can see, the majority of the area in drought is also experiencing a high proportion of poor to very poor range conditions. On the right, I'm also showing the same NASS statistics before a few selected sites to show how conditions have progressed through time and across this drought. I will show a few plots like this, where on the horizontal axis, we have time through 2021, and on the vertical axis, we have the percent land area considered good to excellent. The different colors represent different years, and there's 4 plots, as you can see. From the top to bottom, I'm showing Montana, North Dakota, Minnesota, and Nebraska. All of these locations are reporting very low, good to excellent pasture conditions. In fact, Montana, North Dakota, and Minnesota are all reporting near 0%. Here you can see the progression of bad conditions where Montana and North Dakota have experienced an entire season of poor range and pasture conditions, whereas the slower drought onset in Minnesota shows the conditions deteriorated significantly starting in June. Another significant impact of the ongoing drought has been wildfire and smoke. While some of the smoke is originating from outside of our region, the impacts have been felt by everyone. The bottom 2 graphics represent data sets collected by the GOES satellite a few days ago. On the left, we have a summarized analysis that shows the spatial distribution of light, medium, and heavy smoke concentrations shown from green, yellow to orange. Major fires are also shown in orange dots. As you can see, all of Montana and North Dakota were consumed by heavy smoke, with much of the rest of the area in heavy to medium smoke. The right image is the pseudo-color image showing the raw satellite imagery. State boundaries can be seen in light blue. The smoke from western wildfires, as well as those in Canada, have been significant to say the least. Poor air quality alerts have been issued across the region due to smoke from fires in the region, but also from the western fires more generally. Recent fires in Minnesota and southeast Montana have prompted evacuations, As well as an example, in Southwest Montana, thousands of people living in and near the Northern Cheyenne Tribal Nation were ordered to evacuate, including 2,000 residents of Lame Deer, Montana. There are also recent fires that are troubling in Fort Belknap. Intense precipitation on burned areas caused landslides in Colorado in the Glen Canyon area. Impacts include greater than 100 stranded motorists on I-70 and 40 miles of worth of road closures. Many of the agricultural impacts I'm going to highlight today are driven by the extreme drought conditions in the northern portions of the region. I'm going to go into detail for a few specific cash crops in a minute, but first, in general, the majority of the barley and spring wheat acreage in Montana and North Dakota is considered poor to very poor, with very little good to excellent acreage. Many of the areas are already cutting failed crops for feed livestock. Minnesota agricultural conditions continue to worsen as the ongoing drought intensifies despite a relatively slower onset. As an example, August corn yield estimates of 166 bushels for Minnesota would be the lowest since 2014. In most cases, the percent acreage for most crops considered good to excellent is below or well below that of 2017, a historic flash drought. Let's look at a few examples of crops impacted by drought, starting with barley. On the left, I'm showing a map of the percent poor to very poor for barley acreage conditions. As you can see, Montana and North Dakota have a large percentage of acreage in this category, 67% for Montana and 60% for North Dakota. To see how these conditions have progressed to these very poor states, we will turn to the right. This plot shows crop progress and condition time series for barley. For Montana on the top and North Dakota on the bottom. The colored lines, similar to the previous plots, not the shaded lines, represent the percent good to excellent acreage for the state. In Montana, you can see that there has been a steady decline in good to excellent crop conditions, and that conditions are worse now than in 2017, again, a historic flash drought year. The shaded plots show all condition categories, from very poor in brown to excellent in dark green. For Montana, you can see that this loss in percent of good and excellent acreage was largely replaced with poor to very poor acreage. The trajectory of North Dakota's barley crop was quite similar. However, it should be noted that North Dakota was almost entirely absent from excellent acreage for the entirety of the year. Let's move on to spring wheat with the same style of graphics, except focusing on North and South Dakota this time. The graphics on the left show poor to very poor conditions were dominant in Montana, North and South Dakota, with poor to very poor acreage all exceeding 60% of the acreage. On the right, we can see a similar progression of crop status to that of barley. We can see the rapid deterioration of good and fair acreage throughout June and July, with almost no excellent acreage in either of these states throughout the year. Soybeans in North Dakota and Minnesota also follow a similar narrative. However, North Dakota is the only state in the graphic reporting a majority of acreage as poor to very poor. The shaded plots on the right show steady declines throughout the season of good to excellent acreage, which is, again, replaced by very poor to fair acreage in both states. Again, there was almost 0% excellent acreage in North Dakota for the entirety of the season, as shown by these NASS statistics. It is also important to mention that there have been some wetness issues with respect to soybeans in the eastern part of the region. These impacts have not been as severe as on the drought side. However, time periods of significant moisture have caused issues with the development and disease of the crop. It is also important to note that while I did not highlight corn progress in this portion of the talk, conditions are similar to those of soybeans, relatively poor. Needless to say, the impacts of this drought on producers have been particularly impactful and significant. I do want to take a moment to discuss the psychological and emotional impacts that this drought is having on producers, rural families, and communities. When farming and ranching is your livelihood, there is no alternative but to persevere through these periods of extreme drought. But this can come at serious cost to the mental well-being of the folks working on the land. Drought is often a slowly progressing phenomenon, and this year, long-term stress and anxiety on ranchers and farmers is widespread, as well as on the families and their communities. This drought has had significant impact on the economic well-being of these producers. And in addition, prolonged periods of heat and widespread smoke like we've been experiencing, as well as sudden events like local wildfires, increase anxiety and have both physical and mental impacts on these producers and ranchers. A sense of community loss and displacement often also occurs after sudden extreme events such as wildfire and historic droughts such as this. There may not be an obvious solution to this issue, but having more discussions and acknowledgements of this as a direct and significant impact of drought is a step in the right direction. Okay, let's move on from our current conditions and impacts to the outlook for the upcoming week. Fortunately, favorable conditions, especially in the drought-stricken states across the northern portion of our region of interest, may be in favorable forecast here. Here I've shown the National Weather Service 7-day quantitative precipitation forecast for the United States. Colors here represent the depth of expected precipitation in inches. The expected values in our region range from 1/10 of an inch in that light green color to upwards of 4 inches in red. The key area I'll draw your attention to is a storm track and system that is forecast to drop between roughly 1/4 to upwards of 4 inches of rainfall across Montana, North and South Dakota, Wyoming, Colorado, Nebraska, Iowa, and Minnesota in the next 7 days. As you can see, as we've been discussing throughout this presentation, this region is currently in the most significant and extensive drought. This chance of precipitation is certainly a welcome forecast and is likely to provide some short-term relief. However, in many locations, the precipitation deficits we are currently facing are large and have evolved over more than 6 months, and in some cases have evolved in over a year. These regions with significant and long-standing precipitation deficits and long-standing drought will require more and consistent rainfall to fully alleviate the current conditions. Importantly, the impacts of this drought are already in place, and a rainfall event like this cannot alleviate many of those impacts. Regardless, this is good news in an otherwise rather grim story about drought gripping the north central United States. Here are the Climate Prediction Center's 8 to 14-day outlooks for temperature and precipitation. On the left, temperatures are leaning above normal for the majority of the western portions of the region, as indicated by orange to red shading on the figure to the left. Portions of the region to the east are leaning towards below average temperatures. However, it should be noted that large portions of this outlook's probabilities are rather low, and therefore confidence in this outlook is limited in these regions with the lightest color shading and the lowest probabilities. In the figure to the right, brown shading indicates that the majority of the region with higher confidence, in Montana particularly, is leaning towards below normal precipitation. However, Oklahoma, Arkansas, and states farther to the east and south are leaning above normal rainfall. Okay, moving on to the 1-month outlook now, a little bit longer. On the left, I've shown the temperature outlook, and on the right, precipitation. Starting with the left, the majority of the region is again leaning towards above average temperatures, with some areas forecasted as equal chances. A very small portion of the region is leaning below normal. Again, the highest confidence in this outlook occurs over Montana and parts of Wyoming, so the likelihood is higher here that temperatures will be above normal. Moving to precipitation on the right, Montana, North Dakota, and South Dakota, Wyoming, Minnesota are expected to receive below average precipitation, with most of the remainder of the region forecasted to have relatively equal chances. However, portions of the region to the southeast are leaning towards above normal precipitation. Once again, this outlook's highest confidence lies over Montana and North Dakota. However, the probabilities are still only in the 40 to 50% range, which suggests moderate confidence. Going out a bit further to the 3-month outlook, the story stays about the same. The majority of the region has a greater chance of experiencing above average temperatures and below average precipitation. However, equal chances are apparent in the southeastern portion of the region for precipitation. Again, it is important to acknowledge that the forecasted probabilities are relatively low to moderate, and therefore so is the confidence in this outlook. It will be important to pay attention to the outcomes of this outlook and the other previous outlooks for fall soil moisture levels. Without adequate recharge this fall and into the winter, we can expect drought conditions to persist into the next year. Looking beyond the 3-month outlook, it is important to consider El Nino Southern Oscillation, or ENSO, and changes in the Pacific Ocean sea surface temperatures. These can impact regional air circulation patterns and in turn impact continental landmass air temperatures and precipitation dynamics. So these El Nino conditions or La Nina conditions can impact what's happening in our region as well. I've shown the early August ENSO forecast in this figure. Gray bars on the left-hand side of the graphic indicate that the probability of neutral ENSO conditions dominate for July, August, September forecasts. So in the near term, neutral ENSO conditions are expected. However, blue bars indicate an increasing likelihood of La Nina conditions dominating going into the fall and throughout the winter. So it is expected that La Nina conditions will occur during the upcoming winter. To the right, I'm showing the December, January, February outlook for precipitation. And as of now, we can see equal chances of above normal, below normal, or average precipitation in the extended outlook, highlighting the uncertainty in the long-term forecast and what wintertime La Nina conditions might mean for this region. Finally, let's discuss the seasonal outlooks and seasonal drought and wildfire outlooks. Unfortunately, drought is expected to persist across the northern portion of the region, as shown in brown to the figure to the left, with some further development possible in several states, as shown in yellow. Similarly, on the right, prolonged and persistent drought is expected to increase fire potential across the same region. On the right, regions shown in red show locations with above normal wildland fire potential. And so, to summarize my presentation today, historical drought conditions have occurred across the northern portions of the region, which in some cases have been record-breaking. For example, the first ever D4 drought was identified in Minnesota. However, relatively normal moisture conditions exist in the central and southern portions of the region. There have been significant agricultural impacts due to the historic drought across various crops in drought-affected areas. And similarly, pasture and range conditions are as bad or worse as in 2017 in many of the drought-affected locations. Producers are battling a grand slam of stressors, including severe drought, grasshoppers, fire, smoke, extreme heat, etc. 7-day quantitative precipitation forecasts suggest that there could be some relief in the future. However, much more moisture is needed to alleviate the long-term moisture deficits we see today. The 1-month and 3-month outlooks are leaning towards continued warm and dry conditions for a large portion of the region. Forecasts suggest that a greater probability of La Nina this winter. However, there's low confidence regarding the impact of this event on wintertime conditions across our region. Significant drought and wildfire risk is likely to persist in the northwestern portions of the region, especially if recharge of soil moisture does not occur during the fall and winter. And with that, I would like to say thank you very much. Thank you, Doug. Thank you for having me and Dennis, and provide a few more resources related to this presentation, as you can see here. And,
thank you.
Yeah, pass it back to you, Doug, and we can open up discussion.
Yeah, let's back up to the outlooks a little bit.
Sure.
Please. And let's go to the 1 month. Yeah. So I just want to make sure everybody knows this is for September, September 1st to the September 30th. And go to the next slide. And that this is September, October, and November, sort of combined, if you will, and general thoughts about that. It's clear to us what this is, but you have to look really close at those little words down there where it says valid SON. SON is not my son. It's September, October, November. So anyway, thank you very much, Zach, for that presentation. And we can just leave this up for the moment. We have several questions to sort of get to here or other implications. First, though, let me see if Dennis agreed to say a few words. Okay, great. So Dennis, from USDA Ag Hub in the Midwest, do you want to say, Zach did a fantastic job of hammering on the drought conditions in the North and the West, and to be honest, that's where the critical, I would say, impacts are happening. I've been up there on vacation as well, and it's sort of a bitter pill to drive through some of those areas. Dennis, could you just say a few words, generally speaking, about the rest of sort of eastern part of the U.S., eastern part of the sort of Midwest area in terms of agriculture, corn, soybeans, and all that kind of stuff, in short, in this summer?
Yeah, briefly. I tweeted about that this morning, and if you look at the drought monitor, it really shows the have and the have-nots. Doug, you talked about, and Zach talked about the have-nots, the northern plains, from eastern Iowa, southern Iowa, Missouri, and eastward generally is the area that has been part of the haves. We've had some dry periods. We have some dry periods now, but generally there's been precipitation, so conditions are pretty good. And he showed that on some of the condition maps. There's some excessive wetness in a few places, a few disease issues, but generally conditions are pretty good. So we're expecting yields to be quite good in those areas and kind of balance out the negative on the northern side. Doesn't help out the people locally, but from a large scale perspective, we start talking this time of year about looking ahead towards frost freeze. These warm temperatures are likely going to continue to push crops at or ahead of their 5-year average pace, so we're less concerned about frost freeze issues. And because of the overall wetness, soil moisture recharge is probably going to be pretty good as we go into the fall. We do have some concerns about soil moisture recharge in those plains and northern plains areas where we are dry and where the outlooks are not as optimistic for precipitation. I think those are the main issues right now.
Yeah, I wanted to point out what you were just saying in the last couple sentences there about the situation we were in last year going into the fall and how dry we saw that it was getting dry through last year and definitely into the fall. It was especially in the Northwest or northern plains. That never precipitation really never materialized. There wasn't a great amount of snow cover on the plains. The mountains got fair snow to slightly below. It was a La Niña. So here's the deal. We just talked about La Niña with Zach. Zach said it's going to be. This is what we call a double dip. It's our sort of inside language. Double dip La Niña. So we had it last winter, and we're going to have it again likely this winter. Generally, what those conditions hopefully mean is that greater precipitation chances. And Zach, go ahead one slide maybe.
Yeah.
Yeah. Okay. So it's a weak indication, but it's an indication of above normal precipitation from Montana west, really the high points of Montana west. And as Zach might tell us, it's the high elevations in Montana that really have the best signal or agreement with La Niña. Do you want to expand on that, Zach?
Yeah, it was basically that, in general, the La Niña signal is wetter and hopefully cooler than normal conditions, especially in places like Western Montana. But just because of last season, we're starting to see these conditions, materialize sometimes at higher elevations and, at mid to low elevations where there's critical snowpack. It's generally a lesser magnitude, but just isn't materializing like it does in other years. So that was just last year as kind of an anecdotal evidence of what La Niña might mean for our season. But, it really just depends.
Yeah. And so La Niñas are a little harder to predict winters than, let's say, El Niños, which often are a little better behaving. Go ahead.
I do need to jump in here. Note that this is the old outlook from last month. We didn't get that updated. The November, December, January outlook from this month would expand and cover all of Montana. So
you're right.
Yeah, over all of Montana. And the next month, December, January, February, would be the same thing. So there are slightly better probabilities for precipitation up there for the winter based on the possibility of La Nina.
Right.
Yeah, let me go look for that while we continue to talk a little bit more here, and I'll go ahead and just show that. Yeah, I see. A couple comments and questions from the crowd here. Is the expansion seen in this week's drought monitor okay, is the expansion seen in this week's drought monitor expected over the next few months? Jerry, I'm trying to figure out what you're trying to tell me there. Is the expansion seen? Yeah, so there's the drought monitor and then there's the drought outlook. So maybe go back to the drought outlook real quick, or maybe that's up right now. Hold on. Yeah. So there's the drought outlook. That's of course different than the monitor. That's basically saying we're staying put wherever it's brown. We're staying put. The Climate Prediction Center doesn't expect that area to improve very much through the end of November. We hope it's wrong. The yellow area is an area of expansion, is predicted expansion. The map on the right is more sort of indicating where fires are more likely than normal during the month of August. And I think we probably could throw up a September one there too. Probably would be useful. And I think that pairs it back a little bit. Let me change presenter here shortly. Hopefully I can do this right. Show my screen. What are you seeing, folks? Dennis? Zach?
Yep, see it.
Yep, that's the new outlook.
Okay. There's the new outlook for precipitation for December, January, February, which really, that is an La Nina signature right there, showing that wetness across the northwest part of the U.S. and dryness actually across the southern U.S., at least a likelihood. And there's the temperature outlook as well. So there's that, and slowly getting to people's comments and questions here. Okay, this is for Dennis. I know this is, okay, she admits it's a long shot, but what are your predictions for the 22 growing season as far as soil moisture and winter replenishment for moisture? Oof, bah. That's a tough one. Yep, it's a long shot, but Dennis, you're the best one in the room to answer it.
Okay. I would say, based on where we are right now and the outlook for the fall, we're going to be dry in the northern plains, in possibly central plains and into Iowa. We will probably, and this kind of addresses Jerry's comment or Jerry's question. You know, right now the outlooks don't or lean a little bit towards the dry side. We will probably get some improvement in some areas, but large scale improvement of soil moisture is looking like it's going to be a little more tough in that area. So we're going to start dry in that area. Winter wheat could have some problems with establishment given the dryness, unless we can get some rain started. And the northern plains are going to start, probably start dry because we're going to be dry this fall, starting the fall, and then we'll just see how much precipitation we can get. Wintertime precipitation doesn't help a ton up there because the soils are frozen. Eastern part of the Corn Belt, from Iowa east, Mississippi River to the east, is probably going to be in pretty good shape starting the year because they're not very dry now, and they have a better chance of recovery in the fall, and they don't tend to freeze as much, and there's winter precipitation, so they'll be starting that way. That's the only thing we can say at this point. The thing we would watch out for is if the La Nina would persist into the growing season, there could be some increased risk, but the likelihood of that happening is quite small.
Yeah, this is going to be right now, it looks like a relatively weak La Nina. Often we see the ramifications of La Nina later in the winter, as a matter of fact. So even December, sometimes January, doesn't fully sort of get into the whole La Nina flavor, if you will, in terms of climatology. February is a big one, can be a big one, and definitely March and into April if it holds like the last few La Ninas have gone. Dennis talked about soil moisture. There's a lot of memory in the soil. We remember 2018 and 2019 because we were phenomenally wet, especially in 19. The soils really got saturated, and people were, well, mostly happy about that from an agricultural side. 2020 was not. We lost a lot of that deep moisture, and then this year compounded it even more. And I'm talking very generally. I know some places are fine and some places aren't, but that's sort of the way it's gone. Yes, there are concerns on the Mississippi River, especially the upper Mississippi, for energy. And we're talking about cooling plants down with overly warm water and not a lot of water to cool it down with. Okay, so those are issues right now. There are some water intake issues because they are seeing the worst drought they ever have in some portions of Minnesota, definitely in North Dakota and in places west too. Minnesota is the sort of outlier in terms of places that they don't get this severe drought very often. Not to say that it's not important in some of the western states, more western states, but it's a little more unusual to have this depth of drought, I guess you could say, in places like Minnesota. So yeah, I haven't heard anything about barge traffic navigation issues yet, although more water is being released, I believe, in the Missouri system to make sure navigation system goes through the end of, I think it's October.
I believe there was some concern about if the dryness continues into fall, that there could be needing to reduce loading on barges.
Right. I've got a lot more questions here. There's some appreciation, Zach, for you to recognizing the issues with mental health and drought. It's a tough situation no matter what. It's sort of a quiet one because drought is a slow creeping process that sort of just overwhelms you over time. Along with that comment was a number of a comment about days with smoke cover and mental health issues. People used to sunny conditions where they get this haze, a constant sort of white to gray haze, especially closer and closer as you get to the fire source. There is some issues with that. Okay, what are the implications of higher than average mean high temperatures? And I think this is sort of an ag question, but also a few other things. But it depends on the situation we are addressing. Are you wanting to know? Oh,
yeah, Doug. I was trying to respond to that because I wasn't sure if it's on an ag. Yeah.
Yeah. That's two different people asking a similar question. So, from an ag point of view, go ahead, Dennis. Average high temperatures are bad and low temperatures actually.
Well, when you get very warm, high temperatures, you start putting crops, especially when they don't have much moisture, into extreme or more stressful conditions. You know, they're beyond their usual range where they do well, and when they don't have enough water, that can stress them. You start reducing yield, that sort of thing. It's also bad for livestock. It's bad for humans overall because you have, not just one day of 100 degrees, you have 10 days of 100 degrees. So that starts stressing over after time.
Right. And we are starting to see more and more records for heat, maybe not based on a month, but based on mid-April through mid-August, if you take that sort of time frame, showing that, maximum temperature during those days has never been hotter, which is hard to believe with which is hard to do, especially when we have years like 1936, which of course we all remember. No, actually 1936, in the middle of the Depression, middle of the drought, actually was outstandingly hot. That's all I can say about it. It was crazy. There was a question about flash drought and that definition. You know, I basically just generally say it's a rapidly intensifying drought situation, usually due to well above normal temperatures and some component of wind, obviously without precipitation too. That's something we see during the warm season mainly, and something it's not uncommon to see in different places. Dennis, do you want to say any more, or Zach, do you want to say any more about flash drought? I think Zach, you mentioned it.
Yeah, no, I mean, a lot of the time in Montana, and I think elsewhere, a lot of the time flash drought's associated with really, really high evaporative demand and really, really thirsty atmosphere. And so it is, of course, started generally with a lack of precipitation, but what makes it so fastly evolving is the really arid atmospheric conditions that suck all the moisture out of the ground and produce a really quick, in like 1 to 2 weeks, and on a weekly type time scale.
Right. As opposed to a long drawn out thing like, if you will, North Dakota and really Montana has seen over the last, 18 months, something like that.
Exactly.
Are there ways of measuring or looking at the number of days the areas have been covered by smoke? And I think there are sunshine monitors out there, but I'm wondering, I cannot remember what we know about that.
Yeah, I haven't done any analysis but we certainly could use the air quality sensors across the nation to try to, use some threshold of AQI or PM, 2.5.
I'm wondering though about sunshine measurements, like reaching the surface as opposed, high level smoke as well.
Yeah, measurement data could radiation sensors and stuff could get at that.
And Zach's right. The only problem you have is you have to differentiate between was it cloudiness or was it smoke?
Right. And there are ways to do that, probably with spectral data, reflectance data from satellites, but I don't know of any products that do it explicitly. I have seen smoke products from satellite-based, data sets, but I think it is hard to differentiate reflectance from clouds versus smoke. It's a challenging question.
Okay. So to sum up, I think we're done with the questions, and you guys can certainly comment, but I think the summary of what we really are pushing this month is that conditions west, mostly west of the Mississippi and north of, I-80 really have suffered, and that soil moisture is not in a good place for recharge at this moment. The outlooks don't look great in the near future. Now, I guess, Dennis, you can comment on the next 7 days one more time, but in the near future for recovery, because what you need is long-term recovery for soil moisture, not 5 inches in 1 hour. Okay, so go ahead.
What we really need to have happen is get into the fall and have several larger scale systems that bring a couple inches of rain over widespread areas. We need 2 or 3 of those through the fall, and right now we just don't have the ability to say much about that happening, and seems less likely given the outlooks right now.
Right. The outlooks are not in our favor.
No, they're not.
So I think that is where we will wrap it up. I'm going to say thanks to Zach again for your presentation. There's too much to cover again, but that's the way it goes. And Dennis for his comments, and everybody else who joined in and asked questions. So we appreciate you coming. If you have further questions or your group needs more information, your state, whatever, feel free to reach out to us. We can help with a lot of things in terms of information, or we know who to contact. I'll put it that way. So thank you very much for your time, and we will talk to you next month.